Hello guys, welcome to Ramta Solutions and welcome to your grade 11 physical sciences. Today we are looking at a redox reaction. This is the first video and of course it'll be about introduction and definitions. Okay, so without any waste of time, let's get into it. Okay guys, you have seen these things before, right? You have seen these things before. This is a battery. You have seen it before. And these ones are chains and this is a wrench. As you can see, these things are rusted. We didn't paste fresh wrench or fresh chains, right? They are rusted. So the reason we are showing you this is because we want to show you that this is the real application of redox reactions, and you are going to be doing this right now in grade 11, and in grade 12 you're going to also understand the process of battery making. Okay, you're also going to understand the process of battery making. Okay, now in addition there are other redox reactions. You know photosynthesis, but we're not going to dwell more on this. So a simple thing that we can say to you is that redox reactions, the applications that we know, the production of batteries or the operation of batteries, the rusting of material, right, photosynthesis, and the metal extraction of some of the metal extractions make use of redox reactions. Okay, they make use of redox reactions. So this is one topic that has fast application in industry. Okay, so without any waste of time, let's now get into our definitions. So now the definitions that you are going to need, guys, are: one, you need to know that what do we mean when we talk of a redox reaction? A redox reaction, it is of course a chemical reaction, but this chemical reaction is a chemical reaction in which electrons are transferred. Okay, so with a redox reaction, there is a transfer of electrons. Okay, with redox reaction, there is a transfer of electrons. Okay, now for redox reactions, there are two types of reactions that are occurring. That is oxidation or reduction. Now, what is oxidation? We call it a loss of electrons. Okay, we call it a loss of electrons. So if you look at a redox reaction and you see that electrons are being lost, you must know that oxidation has occurred. This is one definition. When you say loss of electrons, this is one definition of oxidation using electron transfer. Okay, another definition of an oxidation would be an increase in oxidation number. Okay, it'll be an increase in oxidation number. So there are mnemonics that we use. Remember, mnemonics are things that we use to memorize. Okay, so normally for oxidation, the mnemonic that they like using is this one here. It's oil. Okay, it's oil. What is this? Oil means oxidation is loss. Okay, and there's this one, increase in oxidation number is oxidation. So when I was in high school, I used to say, I'm gonna create this mnemonic. I used to say this, iono. I used to say iono. So what is iono? I used to say increasing oxidation number is oxidation. And trust me, many years after high school, I still remember this. Even in varsity, we're still using this. Okay, so remember, these are some of the things that you can use. So when you study, you must come with mnemonics, things that will help you to remember some definitions where possible. All right, but this one of oxidation, which is oil, most sources. Okay, all right, now we have reduction. Now reduction, it is the gain of electrons, right? It is the gain of electrons. Okay, it is the gain of electrons. So with reduction, the mnemonic used is this one, rig. What is rig? Rig means reduction is gain. Okay, reduction is gain. Oil is oxidation is loss. Okay, rig is reduction is gain. So maybe let me write it here. Oxidation is gain. Oxidation is loss. All right. Oxidation is loss. All right. Oxidation is loss. And what is this? A reduction is gain. Gain of what? Of electrons. Loss of what? Of electrons. All right. Reduction is gain. Okay. Now, if you want, you can also define a reduction using oxidation number. When you define a reduction using oxidation number, you will say a reduction is the decrease in oxidation number. So how I used to do it, I used to say, if I know iono, I know the opposite is a reduction. If it's not iono, the opposite is a reduction. So I didn't need a mnemonic for this. Okay. Now, let's go. Now, when we write oxidation or redox reactions, we have what we call a half reaction. Now, a half reaction is basically an oxidation or reduction reaction part of a redox reaction. I have to give you an example here. Okay, I have to give you an example here. An example here will be, let's say this is the overall reaction, copper zinc. Let's say this. So this is the copper. Okay. So let's say this is the reaction that we have. This is a copper zinc cell. Okay. This is an oxidation reaction. So when we say you need to write the oxidation or reduction reaction part of the redox reaction, we mean you will need to write a full reaction showing oxidation reaction and a full reaction showing oxidation reaction. In the third video, I am going to show you how to write that down. For now, not to stay long on this, I'm just going to show you in passing, but video 3 will show you this, okay? All right, so now this says, we're going to say it is zinc solid, giving us zinc 2+. Remember, we need to balance the species. The species, as you can see, the zincs are balanced, but the charges are not balanced. This is 0, this is 2+. So to balance this, it means on the right-hand side, we need to add 2 electrons. You still remember the definition of redox reaction is reactions in which electrons are transferred. And as you can see here, look at this. What do we call this? This will be your oxidation half. Okay, this is oxidation half reaction. Okay, this is oxidation half reaction. All right, this is oxidation half reaction. Why? You have lost electrons. In other words, electrons are on the product side. I'm going to add this with oxidation. How you should see it, electrons are on the product side. Okay. Electrons on product side. Okay, electrons are on product side. Now let's look at copper. So with copper, it is copper aqueous or copper 2+ aqueous. I'm giving us copper solid. It's supposed to be solid here, giving us copper solid. So let's see the species. Copper are balanced, but the charges are not. So we need to, there are already 2 positive charges. We need 2 negative charges so the charges can be balanced. So when we balance them, 2 minus 2 is 0. So the charges are balanced. So what is this reaction? It is a reduction half. Okay, this is a reduction half reaction. Okay, this is a reduction half reaction. Okay, this is a reduction half reaction. Now, what is the difference? Now, as you can see, with reduction, electrons are on the electron side. Electrons are on reactant, electrons are on a reactant side, or reactant side, or a reactant, whichever you like. All right? So this is how you will remember redox reactions. So even when you get to grade 12, this is how you're going to remember them. Okay, this is how you're going to remember them. So if you see that electrons are on the product side, you must know that is an oxidation reaction. And if you see them on the reactant side, you must know that is your reduction half. Okay, so this is it, guys. I'll see you next time. In the next video, we are looking at oxidation numbers. Okay, the next video, we are looking at oxidation numbers. All right, so this is it, guys. Remember, if you would like to get in touch with us, visit our website, www.aramtasolutions.co.za, and you can visit all these platforms. You can send us an email. Even on our website, you will see the icons at the top. You can click on any of them. So you can even send us a WhatsApp message. And if you're looking for a tutor, still, you can subscribe. All right, guys, this is it, and bye-bye.